Hi everybody, it is Wednesday and we have a new mini lesson for Math 7A and Math 8. I hope you're all having a good day and happy April Fool's Day. So today's assignment is the summary to the EQ and then also dividing with exponents worksheet. I'll call it worksheet even though I'm not printing it, but you know what I mean. It's a practice page there. Okay, so go ahead and take out your notebook and press pause whenever you need to stop. I need to make sure I'm talking fast enough so my video is not too long, because this is my second take. All right, here we go. Today we're doing dividing powers with the same base. Your essential question: create an example and explain why the rule for dividing powers with the same base works. You don't need to write the blue part down on any of these slides, but be sure to work out the example using factored form. That's how we're going to do it here. Okay, write this down. Recall, a number divided by itself is equal to 1. So we're going to use that idea in order to figure out what you do, what the shortcut is for dividing powers with the same base. So let's start with this first one, where we have 2 to the 5th divided by 2 to the 3rd. Remember, the fraction bar means division. So 2 to the 5th is in our numerator. We're going to write that out in factored form and put that over 2 to the 3rd in factored form. Okay, because this is all joined together with multiplication and division, we can go ahead and cancel every time we see a number over itself. It's going to become 1. So 2 over 2 makes 1. Another 2 over 2 makes 1. Another 2 over 2 makes 1. And that leaves us with 2 factors of 2 in the numerator. And it's to the second power. So technically it's 2 to the second over 1, which is really just 2 to the second. Okay, so I want you to look at the 5 and the 3 that we started with for exponents. And now look at the 2 that we ended up with as our answer for the exponent. And start thinking about how we got from those initial exponents in the problem to the exponent in the answer. Let's try a second one. So we've got x to the 4th divided by x to the 6th. So x times x times x times x in the numerator over x times x times x times x times x times x in the denominator. So every time we see the variable over itself, that also equals 1. So we've got one pair that equals 1, a second pair, a third pair, 4 pairs of x over x, each one of them equaling 1. So we notice that the x's that are left over are in the denominator. They need to stay there. So we have 2 factors of x, so that's x to the second power. And on the top, we can't just leave it blank. So this is technically 1 times 1 times 1 times 1, which is going to give us just 1 on the top. So we get 1 over 2 to the second. Go back and look at the exponents we started with, a 4 and a 6, and look at the exponent we ended up with. And think, how did we go from a 4 and a 6 and end up with a 2? So think about that, pause it if you need to, and then we'll move on to the next slide. Okay, hopefully you noticed, back on this one, that 5 minus 3 gives us 2 here in the first example. And if I take the larger number, 6 minus 4, that also gives us 2. We notice that in the second example, the x's are in the bottom because there are more powers of x, so that's where they're left over. So let's look at what the rule is. I want you to copy this rule down. To divide powers with the same base, subtract the exponents. When you're doing division problems, it's also really important, and write this down as well, to pay attention to whether the factors are left in the numerator or the denominator, like we did in those first 2 problems. We look to see where there were more factors to begin with, and that's where the leftover factors would also be. Okay, remember, you don't have to copy anything in blue, but let's go ahead and use that rule to simplify the expression. So we definitely wouldn't want to write these out with these big exponents. We've got y to the 20th over y to the 8th. So we notice that let's look and see, where do we have more powers of y, in the top or in the bottom, in the numerator or denominator? So obviously that's in the top. So we're going to put our y, we can put this over a little fraction bar there. So we have y to the 20 minus 8 power, which gives us 12. So we get y to the 12th over 1, which is really just y to the 12th. We don't need to have that 1 underneath. Anytime we have that, we can just get rid of it. Over here, we have two different bases. I'm going to make my fraction bar. Let's look at 9. That's our first base. And let's look at the exponents. We have 9 to the 3rd divided by 9 to the 10th. We see more powers of 9 in the denominator. So we're going to put our 9 down there. And how many powers of 9 are left? So if we subtract the exponents, 10 minus 3 is equal to 7. So we get 9 to the 7th in the denominator. Next, let's look at the x's. That's our second base. We have x to the 6th divided by x to the 8th. So think about it. Where do we see more powers of x left over? Or more powers of x to begin with? We have more in the denominator. So we're going to go ahead and put our x in the denominator. And 8 minus 6 is going to give us 2. So we have x squared in the denominator. But if we had done this out the long way, we would have done a whole bunch of canceling, and that would have left just a whole bunch of 1s to multiply in the top. So make sure we can't just leave the top blank. We need to put a 1 in the top. It's going to be 1 over 9 to the 7th, x to the 2nd. All right, now it's time for you to try. Go ahead and try these two examples. Pause the recording, and then put it back on to see if you did them correctly. Go ahead and pause right now. Okay, you're back. Let's look at the first one. Let's see where do we have more powers of 9? Are they in the numerator or denominator? So it looks like we have more in the denominator because the power is 27. So we know that we're going to have powers of 9 left over in the denominator. How many? Well, what's 27 minus 17? That gives us 10. So we get 9 to the 10th in the denominator. And we need to put that 1 in the numerator because you can't just leave the top without anything. There would have been a whole bunch of canceling going on. There would have been a whole bunch of 1s multiplied together to give you that 1 on the top. And on the second one, your first base is 2. If you look at the powers on 2, you've got 2 to the 11th divided by 2 to the 4th. So we have more powers of 2 in the numerator. We're going to put the 2 in the numerator then because that's where the leftover powers will go. So 11 minus 4 gives us 7. So we're going to have 2 to the 7th in the numerator. Then let's look at the z's. We have z to the 18th divided by z to the 24th. We have more powers of z in the denominator. So let's put our z in the denominator. And let's see how many powers of z are going to be left over. So 24 minus 18 is equal to 6. We'll get z to the 6th. So you get 2 to the 7th over z to the 6th. The last thing I want to talk about is 0 as an exponent. So this is related to division because now that we know what we're doing with division and what the rule is, we'll be able to figure out what 0 is as an exponent. Make sure you're not writing anything that's in blue. So, but the directions do tell us to write out this problem in factored form. So we have 3 to the 2nd, that's 3 times 3 over 3 to the 2nd, 3 times 3. Doing what we were doing earlier, every time we have a number over itself, we can go ahead and cancel it and it becomes 1. Well, we have a second pair of 3's right here that cancel it, becomes 1. So now you have 1 times 1. The whole thing just makes 1. Let's go ahead and redo the problem using the rule. So if we have 3 to the 2nd over 3 to the 2nd and we subtract the exponents, we're going to have 3 to the 0 power. Well, these must be the same because they have to come out the same in order for our rule to work. So that's telling us then that 3 to the 0 must be the same as 1. So we're seeing that 3 to the 0 power is going to be equal to 1. In fact, this is true every time you get any number to the 0 power. Here's one more way we could look at it. If you have 3 to the 2nd over 3 to the 2nd, that's the same as 9 over 9, which again is still 1, right? So it has to work out to the same answer no matter what method you choose. As long as you're doing something correctly, it should come out to the same answer no matter what. So from that, we can get the understanding that anything raised to the 0 power is going to be equal to 1. So these may look tricky, but they're actually really, really simple. 205 raised to the 0 power, what's that going to be? You got it, just 1. Negative 99 raised to the 0 power, what's that going to be? Yep, same thing, still just 1. XYZ, the whole thing raised to the 0 power, what's it going to be? Yep, still the same thing, just 1. All right, now you can go back and answer that essential question. Again, make sure you're using factored form to work out the problem, just like we did in the first 2 problems, so that you can show why the rule works. Why does it work that you can subtract the exponents when you are dividing powers with the same base? So do it out the long way and do the canceling to show us with that. Okay, great. Thanks. Have a great day, and we'll talk to you soon. Bye-bye.